Hi students, now we will go to another concept that is called the stereographic projection. Okay, so what is the concept? It is coming like we have our real space. We just generally talk about the extending to zero or extending to infinity. Okay? So in the case of a real axis, there is real. In the case, this is your real axis. Okay? So here is the x, and we have generally 0, 1, 2, 3, etc. It goes like that up to infinity. So in the case of a real axis, when you are talking about x tending to 0, you have a clear picture in your mind. That means, suppose your x is somewhere here, then x tending to 0 means we are going towards this point, isn't it? Or suppose if your x is here, that means on the positive side, then we are coming to this point. So that is some meaning. It has a clear meaning and you can picturize it easily, or you can imagine it easily. And on the other words, in the other hand, like x tending to infinity. What about this? X tending to infinity, that also has a clear picture in your mind, because this x is going further and further towards the, or it is diverging without any limit. So it is going to infinity. So this is a positive infinity or negative infinity, like that. Now we come to our complex number. What about the situation in the case of a complex number like z tending to 0 or z tending to infinity? What does it mean? How to represent it? That is a big question in our hands. So we will look at it. So the problem what we are going to address in the case of an imaginary situation or in the complex situation, what is the meaning z tending to 0 and what is the meaning z tending to infinity? Because our problem arises in this way, because z is equal to x plus iy. Now you take a complex plane. So this is your real and this is your imaginary. Where your z is located? Z is located based on the value of x and value of y. Isn't it? It may be exactly on the real axis if you don't have any value. It may be purely on the imaginary axis if it doesn't have any x value, or maybe here, or maybe here, or maybe here. It depends. It depends upon the value of x and y, where your z is located. So now you are giving the limit z tending to 0. This z tending to 0, it may be like this, maybe like this, maybe like this, or it may be like this way, or it may be like this way, or this way, or there are infinite number of possibilities where we are z tending to infinity, z tending to 0, because for each x and y value you have a specific point on this complex plane. So this tending to 0 means the point, the original point may be anywhere in this plane. Okay, so you have infinite number of points. Okay, So this is a problem to represent this way. And what about the z tending to infinity? That become more complex than this. Okay? Because z tending to infinity, it may goes to infinity if x goes to infinity, or it may y goes to infinity, or it may x and y goes to infinity. So there are different what is called possibilities. It may be by x tending to infinity, your real part is going to infinity, or it may be purely by your imaginary part going to infinity, or both are going to infinity. Then there are so many possibilities. How to represent it? That we cannot really represent on this plane, complex plane. So the thing is more complex. So in order to represent this, we have to go for a stereographic projection of these complex numbers. Okay, that way we have to study. I hope you understand what is the problem in our math. Why you need this stereographic projection. So this is good. Stereographic. Projection. So this we are going to add this. How you can make this stereographic projection? So first I will draw a complex plane. This is my complex plane. What I am going to do here, I have the axes like this. Okay, and here you have your x and y. You have to keep in mind, instead of making a vertical plane, here I made a horizontal plane. I just spread the plane like this, like on a chair. Now, what you do, you take a unit radius or unit sphere. Okay, actually I spread this complex plane on a table. You just imagine like you have a table and I spread this my complex plane on it, and I am taking a unit sphere. This unit sphere, how I am keeping? First hemisphere, that half part of the sphere on the top of your table, and other half on the bottom of your table, like that. So I am not that much good in drawing, but you have to adjust with me. Okay, I will just pause it. Let me draw it, and I will come back. Okay. Okay, I drawn it like this. This is how you have to imagine. This is your complex plane. Okay, this is your complex plane, and I drawn it in a three-dimensional way. And this unit sphere, the half of this above the complex plane and half of this in the bottom. Okay, like that. That is it. Like you are just keeping a ഒരു പകുതിയായിട്ടുള്ള ഒരു സ്ഫിയർ ഇങ്ങനെ കുമ്പിടുത്തി വെച്ചിട്ടുണ്ട്. നമ്മുടെ വീട്ടിലൊക്കെ ടേബിളിൻ്റെ മേലെ എന്തെങ്കിലും ഇങ്ങനെ കുമ്പിടുത്തി വെക്കില്ല. അപ്പോൾ അതുപോലെ ഏകദേശം ലൈക്ക് ദാറ്റ്. Now, what is the importance of this sphere, this unit sphere? Here, each point on this complex plane, for example, you have a point here. So this point has a, and what is this z1, and this z1 has a value of some x1 plus I by 1, because depending upon the x value and y value, each z point, okay, each z value has a unique point on this plane, okay. It depends upon the x and value where it is located. Now what do you want to look at this? Here this is, I am taking as the z-axis, x1 and z, okay, and this point I am calling it as capital N, and this point I am calling it as the origin O, and this ON is the magnitude of this length is 1, because you taken a unit sphere, okay, so unit sphere means the radius is equal to 1, okay. Now what is the importance of this sphere? If you take any point on this complex plane and you make a line from this particular point to this north pole, so this will cut at a unique point on this sphere, wherever may be the point on this complex plane. For example, if you just draw a line from this particular point to this point, okay, I am drawing it like this, okay, so the remaining going to sorry, my line is not reference straight, this, yeah. So this will cut this point and going to this end. If you have some other point, maybe you have a point here, another point I am putting this z2. So just to make a line from this point, then after that this is going, oh my gosh, like that. So this point is cutting here on the sphere, this point is cutting here on the sphere, see, after that it is going to inside. So you take any point on this complex, that will make a unique cutting point on this, okay. So this way you can say this, on this complex plane, this point is exactly here, and what is our issue? The issue is what was issue? Z tending to 0 and Z tending to 0. First we will take Z tending to 0. Then what about Z tending to 0? Z tending to 0 means any point on this complex plane that will cut this sphere, this unit sphere exactly at the north pole N, because it won't, but when it moves to 0, it will exactly cut at this point only. It won't touch anywhere on this sphere. Can you imagine it? Okay, like you have a sphere, half of the sphere that is kept on a table. Okay, so you take any point on the table, make a draw towards the north pole of that sphere. Okay, when you draw a straight line, it will cut somewhere on this sphere. Okay, നമ്മൾ സാധാരണ ഒരു ഫുട്ബോളിന്റെ പകുതി, അപ്പോൾ പകുതി എടുക്കുമ്പോൾ അതിൻ്റെ നോർത്ത് പോളിൽ നിങ്ങൾ സ്ട്രെയിറ്റ് ലൈൻ ഇതിൽ നിന്ന് വരച്ചു കഴിഞ്ഞാൽ ഏതെങ്കിലും ഒരു പോയിന്റിൽ അത് പോയിട്ട് കട്ട് ചെയ്യും. അപ്പോൾ ഈ Z, when this Z tending to 0 means it cut only at the north pole. Okay, so you got a imagination, clear imagination how it comes. So this, wherever your point, it has only a unique definition like this. Anywhere, whether it is here or here or here or here, wherever it will do the same. Now, second issue we have to address, z tending to infinity. What would be? Can you imagine it? You just think about it. This is your z point. I am taking this point. This point is going to infinity. When it goes to infinity, that means it will go further and further on this plane. Okay? So when it will go further and further, what will happen? This cutting point eventually move like this. From this point it will just move. When it moves a little further, it cuts here. Little further again, it will cut here. Okay? Like that. This way, this will move towards the end, because when you move, because you know, initially it was like this. Okay? Shall I make how to make it? So this is my north pole. Okay, the radius of my what is called sphere, hemisphere, and my z point is here. Okay, on the corner. Now I am just moving this z point further and further. What will happen? This inclination increases. Finally, it to make an angle 90 degree, exactly 90 degree with this vertical. Okay, that means your z point move to the infinity. You understand what is the concept? Okay, so this z point will go further and further. This cutting point, this also move towards this end. Finally, when it reaches infinity, it just make a tangential. Actually, it won't cut end. It just pass through the point end. Okay, as a tangential. Okay, so you got the concept, the real concept, how z tending to infinity. So this is called the stereographic projection of your complex plane. Okay, so this is a good concept. You will get a lot of idea about it. And also from this stereographic projection, you will also get the x and y values. For that one, what you have to do, you will just take the bisection of this. Okay, you may just check it out. Okay, I hope you understood how you can say about z tending to 0 and z tending to infinity from this stereographic projection. So, in order to get x and y, you have to just do some trigonometric relations when you look at the x and y. I will just make the cross section of it. So I will just take only not in 2D, sorry, not in 3D, I am taking the 2D of it. Okay? X and y. X axis on the okay. I am just taking the cutting, so I will just make my z remains the same because your sphere comes like this, and this is your y. Okay, and now the sphere is like this. This is your unit sphere. Okay. Again, sorry, this is not exactly centered at 0, but you have to take it like that. Okay. And now I will take any point here. This is my point. And this point, when this is my end, okay, on the top of the north pole of the sphere. Okay. And from this one, not here, I just so this is the point of y. Actually, you have a plane like this way, okay? And this is one axis, and your x-axis is supposed to be like this, pointing towards you. And this is the plane. I just made the bisection of it. So actually, your point is touching on this point of the sphere. So this point. I am just calling the length. This much length is eta 1 and this length is eta 3. Okay, I am just calling for my convenience. Theta 3 and this is theta 2. And this point I am calling this Q, and I may call this as this is already O, origin O, and I am calling this point as P. Okay. Now, actually this point is located at this theta 1, theta 2, theta 3, some general point of this sphere. Okay. But we are considering only 2D. Now, and one more thing, because this is a unit sphere, so theta 1 square plus not the theta, this is sine 2 square plus 3 square is equal to 1, because you have a unit sphere. You know, for a unit sphere, generally in the Cartesian coordinate we coordinate x square plus y square plus z square is equal to 1. Same. Now, in this one-dimensional situation, we have this n. Another thing is this n is equal to 1 because it's a unit sphere. Okay. Now, what we will do? We will just take our relation PO versus divided by PT. Okay. Because if I call this point as T, I am calling this the point at T. So PO versus PT is equal to by trigonometric relation NO by what is called QT, because this is Q. So here also we project this like this. Q into this NO divided by Q. Okay. That is our basic electrodynamics that you have studied in your lower classes. What about the PO? PO is Y. Okay. And what about PT? PT is nothing but y minus sine 2. What about NO? NO is nothing but 1 divided by QT. What is QT? QT is sine 3. So from this one, if you rearrange it, you will get, you can just check it out at your home. You just separate the y, then y, you will get it as y is equal to 2 divided by 1. So you work it out your home. Okay, and this is the relation for y. Based on where your projection is acting on the what is called sphere. Okay. Now, if you take the other plane, like instead of taking this plane, this vertical plane, you take the horizontal plane. Then again you will get the same kind of relations, and your x will be what x. You can work it out at your home. X will be 1 divided by 1 minus sine 3. So this is the relation. So now you will understand, or you can get a real picture about whether x or y is going to infinity, means it is intersecting the points on the sphere. And okay, one more thing, that this sphere that we used to make the stereographic projection, that is called the Riemann sphere. Riemann. Okay. So these things we will, the Riemann lot of things about the Riemann we will study in the upcoming classes. Okay, I will just start with multi